Alright folks, so moving on to the back page, we've got some more degree 3 functions. So folks, going to our y equals, are we going to use a big minus sign or a little negative for this one?
Negative.
A little negative. So little negative x, caret button 3, arrow over to escape the exponent, and then plus 2x, plus 2x. Ooh, fancy. So it's like a cubic function, but there's an extra little bump up in there. So, ooh, we forgot to state our y-intercept for this one. Our y-intercept would be at not 2, but 0, 0. So notice on this one, if I cover up those x terms with zeros, we have nothing left. So my y-intercept is going through 0, 0. So swooshing down on the left side of the y-axis, then swooshing up through the y-intercept, and putting arrows on the end. Now this one, our right arrow is going down, and our left arrow is going up. So opposite directions, going up and going down. All right, folks, we're going to quickly graph these last two. Go to y equals, hit your clear button, x cubed, arrow over to escape the exponent. Little negative or big minus sign? Big minus sign, minus x plus 1. Where's our y-intercept going to be?
1.
At 1. So 0, 1. We can put an exact point there. And hey, this one's similar to that one we just did. So going up and coming down a little bit, and then whoop, back up. Now on this one, I got one end arrow going up and another arrow going down. So hold up just a second. So these two graphs are pretty similar. They both kind of curved up and then curved back down. This one's arrow is going up. This one's arrow is going down. And then this one was down and then up. So make a prediction on what you think number 12 might do. What's the y-intercept of number 12 going to be? 0, 0, 0. Put a point there. And when we type in -2, we're going to use a little negative. -2, x. Ooh, this one's a power of 5. Degree 5, everyone. Let's see. Caret button 5. Arrow over to escape the exponent. Plus x squared. Arrow over to escape the exponent. Minus x. Not negative x. Minus x. We hit graph. Oh, okay. So, kind of looks like a cubic. But it is not because it has a power of 5. So, swoosh and then down. So we're going to talk about patterns next. And I don't really want to answer these questions. I just kind of want to talk big picture. What is the biggest difference between the even degree ones and the odd degree ones?
Evens look more like quadratics and odds more look like cubics.
Yep. So going back to what we know from the last chapter, quadratics tend to look like this or like this with their end behavior. Cubics tend to look like this, or if it's been reflected, like this. So what I'd like you to do is even degrees. A good reference point is quadratics, where the arrows are going up and up or down and down. We can say that the end behavior is in the same direction, either up and up or down and down. Whereas odd degrees go in different directions. Either up on one side and down on the other, or down on one side, up on the other. Now the reason I'm drawing these arrows disconnected is because on some of those even degrees, we had some strange little things happen in between, like maybe we're doing this, making a W shape, or maybe it's just a regular quadratic. Maybe this one's just a regular quadratic. So what even degree tells us is not about all the curves that happen in the middle of the graph, but specifically it tells me that the end behavior goes in the same direction up or the same direction down, whereas odd degrees go in different directions. And next to odd, I usually like to draw a little dancing guy doing a dance for odd degrees. So that's one big difference between even degree functions and odd degree functions. Even degree has some similarities to quadratics, y equals x. Odd degrees are a little bit more like cubic functions. What's another odd degree function that we saw last unit? Not square root, not absolute value.
Linear.
A linear function. And if you're like, no, a linear function has a degree of 1. It's odd degree 2. And if you think of a line with its slope going down and slope going up, it doesn't have any curves in between, but the end behavior is really doing the disco dance. So odd degrees, different end behavior. Even degrees, same direction. The last thing we're going to talk about is the arrows going in the same direction, or no, about the graph going up on the right or down on the right. Your graph goes up on the right if you have a positive leading coefficient. It goes down on the right if you have a negative leading coefficient. So this would have a positive leading coefficient. This would have a negative leading coefficient. This one would have a positive leading coefficient. This one would have a negative leading coefficient. So the last thing that we're going to do is I'm going to use